Hello everyone, and welcome to another instructional video. Today we will be solving an inequality step by step. The inequality we will be working with is 5o minus 3 is greater than or equal to 10. By the end of this video, you will not only have the solution in inequality form, but also in interval notation. So let's get started. To solve the inequality 5o minus 3 greater than or equal to 10, we start by isolating the variable term on one side of the inequality. In this inequality, the variable term is 5o. To isolate 5o, we need to get rid of the minus 3 that is being subtracted from it. We can do this by performing the opposite operation of minus 3, which is addition. Specifically, we will add 3 to both sides of the inequality. This step ensures that the equation remains balanced because we are performing the same operation to both sides. The inequality 5o minus 3 greater than or equal to 10 becomes 5o minus 3 plus 3 greater than or equal to 10 plus 3. When we simplify this, we see that the minus 3 and plus 3 on the left side cancel each other out, leaving us with just 5o on the left side. On the right side, we need to add 10 and 3, which equals 13. So the inequality now reads 5o greater than or equal to 13. In this first step, we have successfully isolated the variable term on one side of the inequality. This is a crucial part of solving the inequality because it sets us up to find the solution for O. For the inequality notation and interval notation forms, we recognize that from 5o greater than or equal to 13, the variable O must be greater than or equal to 13 divided by 5. This maintains the inequality's balance, as division by a positive number doesn't change the inequality's direction. The solution in inequality notation is O greater than or equal to 13 divided by 5. For interval notation, we showcase all possible values for O. Since O is greater than or equal to 13 divided by 5, the interval starts at 13 divided by 5 and includes all numbers greater than that. The interval will be written as starting from 13 divided by 5 with a square bracket, extending to positive infinity with a round bracket. It's important to note that square brackets and round brackets have specific meanings in interval notation. Square brackets indicate that the endpoint is included in the interval, indicating greater than or equal to. Round brackets indicate that the endpoint is not included, showing just greater than. Here, we use the terms starting from and extending to show these meanings. In step 2, we need to further isolate the variable O by getting rid of the coefficient 5 in the inequality 5o greater than or equal to 13. To isolate O, we will divide both sides of the inequality by 5. We choose to divide because we want the coefficient of O to become 1. This will give us the value of O alone on one side of the inequality, which ultimately helps us solve for O. The inequality 5o greater than or equal to 13 becomes 5o divided by 5 greater than or equal to 13 divided by 5. When we simplify this, the 5 and 5o divided by 5 cancels out, leaving us with just O on the left side. On the right side, we have 13 divided by 5. So the inequality now reads O greater than or equal to 13 divided by 5. Here, we have simplified the problem to the point where O is now by itself on one side of the inequality. This is the final step because we have successfully isolated the variable O. Next, let's express the solution in both inequality notation and interval notation. In inequality notation, the solution is O greater than or equal to 13 divided by 5. For interval notation, we showcase all possible values for O that satisfy the inequality. Since O must be greater than or equal to 13 divided by 5, the interval starts from 13 divided by 5 and goes to positive infinity. The notation will be 13 divided by 5 to positive infinity. This step is important in concluding our solution because we have now expressed the values of O in both notations, giving us a clear understanding of the range of possible solutions. Thanks for watching. I hope this video has helped, and if it did, please drop me a like.